Welcome students. Today we'll take up a topic which you all know, but I'm not sure whether you know it correctly or not. The reason behind it is in last few days I was watching some videos and I figured out that this particular topic actually was not well informed to everyone. That includes teachers as well. So today we'll talk about pseudo force. So before we understand what a pseudo force is, just by the name you can say something which is not actual. To understand that, we need to understand a couple of things. First is the inertial frame of reference, and second is the non-inertial frame of reference. When we say inertial frame of reference, that means either there is no motion, that means it is at rest, or there is some motion with a constant velocity. Wherever there is some kind of an acceleration, it could be radial acceleration, it could be linear acceleration, those motions come under non-inertial frame. Now, when we say non-inertial frame, why do we need to separate them? The reason we need to separate them, because in non-inertial frame, Newton laws are not applicable directly. That means Newton laws fail. The problem is, how do we then make Newton law work in those cases? To make the laws work on those situations, we come up with a concept, pseudo force. Pseudo force, which is kind of a fictitious force, apparent force, whatever you name it, it's not a actual force, and it has no capacity of performing any action. It is just a force that we consider to balance things out so that Newton's law works. Okay, I will give you a small example. Let's take a vertical rotational motion. Okay, and a body is tied to a string at the center, and this is, let's say, rotating in this direction. So what are the forces that you can actually see? One force that we know is actually acting inward, which is the centripetal force. And one thing that you can see is this body is actually having a velocity tangential. That means at this instance, if I cut this thread, this body will move tangential to this position. So the problem happens, how do we actually explain that this body is rotating? Because the tension is towards this direction, the centripetal force is also in this direction, then how it is balanced outwards? We cannot explain it. And that is where the concept of non-inertial reference frame comes in. So if I'm sitting outside, this is an inertial reference frame. So, okay, this is inertial. Now, to calculate all the forces and determine the what exactly is the centripetal acceleration, we sit here at the origin, okay, with x and y. So this is the non-inertial reference frame. If you are sitting at this position, and let's say you cut the thread, you will see that this ball will go radially outward. Actually, it doesn't go radially outward, it really goes this tangentially, but you are also rotating with this body. So you will, at let's say after some time, you will see this position. So body will feel like it's going like this, after some time like this. So you will always feel that the body is going radially outward. So that's just a feeling, but that's not what is actually happening. To actually counter this, you come up with a concept that there is a centrifugal force. And you try to balance this centrifugal force with the tension and everything. But this centrifugal force is not a real force. Okay? It is just used for calculation. Somebody is saying that because of centrifugal force, it is rotating. It is not. So I have already talked about this centripetal force. So is it the only thing that is keeping it in this rotational motion? There is another thing that is called as inertia. What does law of inertia, that means Newton's first law, say? Newton's first law says that because of inertia, the body will be at rest or will be in a continuous motion with a constant velocity until and unless a force is applied. So when you cut the thread, there is no force is applied. So the velocity will try to move it tangential, and this is the inertia. So the ball is trying to go tangentially, but the thread is trying to pull it towards it. So the inertia and the centripetal combination actually keeps this rotating in circle. If anything is missing, it will not rotate it in circle. Either it will fall down radially inwards or it will go tangentially. But centrifugal force is only for calculation. So a body rotates in a circular motion due to couple of things. One is centripetal force and one is the inertia. It's not the centrifugal force. Is that clear? Thank you.